This interactive figure or animation that we can find on masteringastronomy.com allows us to see some of the different parts of a wave or ways we describe a wave that are things that we need to know. When we picture a wave, often I think we use this visual of a sinusoidal wave, like a sine function or a cosine function. You see it just repeats itself over and over, up and down in a very predictable way. And so this is how we would visualize a wave if we were able to take a snapshot of it and freeze it in time. If we take the distance from one crest or high point to the next crest or next high point, that distance, you notice, if we take this piece of the wave and we keep tacking it onto each other, we produce this picture. So this is the whole fundamental piece of a wave, and we call it the wavelength. And so it's measured in units of distance. So that's one way or one quantity about a wave that we need to know. The amplitude is basically how far is this disturbance go from, a zero disturbance. So it's, for the entire wave, it's half the distance from the middle to the very tip of the crest. And that's the amplitude. The amplitude can be different values depending on the wave. The frequency is something that sometimes might be difficult for us to really understand, but basically it's describing how quickly the wave oscillates between high and low points. And the best way to think about this is, as in this picture, we're at a particular location. We're standing as a wave is passing us. Notice this wave moving right below this spot. And we're using this leaf to show us the frequency, because the frequency is essentially the number of waves that pass us as we stand motionless in a unit of time. Every time this light blinks, a complete wave has passed our location. Notice that every time this leaf gets to a high point, this blinks. So the frequency, again, is the number of waves that pass a particular point per second. Finally, the speed of the wave is basically how fast is this wave passing. And so while amplitude is nice to know, the three very important quantities that we need to know are wavelength, amplitude, and speed. I mean wavelength, frequency, and speed. Sorry about that. And the relationship between the three are that the wavelength times the frequency is equal to the speed. And one last thing, let's just look at a comparison between the electromagnetic waves, which is the light that we're studying, and a water wave. The water wave is really easy for us to understand. We think of the waves in the ocean, for instance, and the waves are passing us at a very slow speed. It's the water that's actually disturbed in a water wave. Light is a little harder for us to understand because it consists of quantities or things that are oscillating that we don't actually see, which are the electric and magnetic fields, are the things that are oscillating instead of the water. And of course then the speed of these oscillations, the speed of this wave is very, very high. It's the speed of light, which we have learned is the fastest that anything can move. So hopefully this little picture helps you understand some things about waves.